Today we're going to be talking about section 5.3, solving trigonometric equations. Let's first take a look at the graph of sine of x equals 1/2. You can see the graph of sine of x and the line of y equals 1/2. Each place that the graph sine of x hits y equals 1/2 is a solution. If you continue the graph sine of x off to infinity on either side, you'll see that it hits the line y equals 1/2 infinitely many times. So therefore, there are infinitely many solutions. Now let's look at sine of x equals 1/2 on the unit circle. Here, you can see that pi over 6 and 5 pi over 6 are solutions to the equation. On the unit circle, we know that you can go around an entire rotation 2 pi from either solution and get another solution that is equivalent. You can go around the unit circle infinitely many times from pi over 6 or 5 pi over 6 to get infinitely many solutions again. So we know the solutions of sine of x equals 1/2 are 5 pi over 6 and pi over 6. But if you add 2 pi as many times as you'd like, you can also get 13 pi over 6, 17 pi over 6, or by subtracting 2 pi, you can get negative 11 pi over 6 or negative 7 pi over 6. Just like in the other example, you can add 2 pi infinitely many times to get infinitely many solutions. To find the general form, you'll start with the first two solutions, pi over 6 and 5 pi over 6. You can then add 2 pi to both of them infinitely many times. Adding 2 pi a lot of times can get very tedious, so we're going to find a new way to do it. So 2 pi is being added together n times. So we can change this to write it as a form of multiplication. So you'll start out with pi over 6 and then add 2 pi because it's the period of sine, and then multiply it times n so that you have pi over 6 plus 2 pi times n. You can do the same with 5 pi over 6, leaving it as 5 pi over 6 plus 2 pi times n, and that's the general form of the solution. Our past example that we've been looking at had infinitely many solutions, but if you are given parameters, there are a finite number of solutions. So let's look at cosine of x equals square root of 3 over 2 between 0 and 2 pi. If we put parameters between 0 and 2 pi, that's the parameters for the unit circle, so we know that there can only be two solutions. So one of the solutions is pi over 6, and the other solution is 11 pi over 6. So once again, since we are given parameters 0 to 2 pi, we know that there are not infinitely many solutions, and there are only going to be the two solutions that we found. So the only solutions that are between 0 and 2 pi, once again, are pi over 6 and 11 pi over 6. So now let's look at how to solve the equation 2 cosine of x minus the square root of 3 equals 0 between 0 and 2 pi. To solve an equation, you're trying to isolate the trig function. So you're trying to isolate the cosine of x here. Just like solving a normal equation, what you do to one side, you have to do to the other. So let's first add the square root of 3 to both sides, leaving us with 2 cosine of x equals the square root of 3. Since you're still trying to get cosine of x by itself, you'll divide 2 by either side, and then you have cosine of x equals the square root of 3 over 2. So as you can see from our previous example, it's still between 0 and 2 pi, so our solutions are pi over 6 and 11 pi over 6. Now let's look at solving some more equations in the general form. Let's first look at number 1, 2 sine of x plus the square root of 2 equals 0. So you're trying to isolate sine of x. So to do that, you'll subtract the square root of 2 from both sides. Then you have 2 sine of x equals negative square root of 2. Then you'll divide by 2 on either side to try to get sine of x by itself again, leaving you with sine of x equals negative square root of 2 over 2. But make sure you pay attention to the sign. So this one is negative, so when we look at our all students take calculus, it will be in the bottom 2 quadrants. So then our solutions are x equals 5 pi over 4 and x equals 7 pi over 4. But remember that we want it in the general form. So once again, we're going to look at the period of sine and add it to the solution. So 5 pi over 4 plus 2 pi n and 7 pi over 4 plus 2 pi n are the solutions for the general form. Now let's look at cotangent of x squared minus 3 equals 0. So you're still trying to get cotangent of x by itself, so you'll add 3 to both sides, and then you're left with cotangent of x squared equals 3. Then you'll take the square root, so then you have cotangent of x equals the square root of 3. Cotangent of x is the reciprocal of tangent of x, so in order to find the solutions for cotangent of x equals square root of 3, we need to find the solutions for tangent of x equals 1 over square root of 3. So tangent of x equals 1 over square root of 3. Then you need to rationalize with a fancy 1. So you'll multiply by the square root of 3 over square root of 3 to get square root of 3 over 3. So the solutions to this are pi over 6 and 7 pi over 6. So both of those solutions will be usable for cotangent of x equals square root of 3. So the solutions for this are also pi over 6 and 7 pi over 6. But we still want this in the general form. So the period for tangent and cotangent is pi. So you'll add pi n times. So the solutions are pi over 6 plus pi times n, and 7 pi over 6 plus pi times n. So let's look at one more equation in the general form. This one is 1/3 sine of u plus 1/3 cosine squared of u equals tangent squared u. When solving trig equations, they all need to be with the same trig function. So looking at this, you should be able to tell that sine of u squared plus cosine of u squared is an identity with 1, and they both share a common term, 1 over 3, so you can factor that out and have 1 over 3 plus sine of u squared plus cosine u squared equals tangent of u squared. So you know that sine squared u plus cosine squared u equals 1 from the Pythagorean identity. So then you have 1/3 times 1 equals tangent of u squared. So then you'll take the square root of both sides, leaving you with square root of 1 over square root of 3 equals tangent u. Then you can rewrite that as 1 over the square root of 3 equals tangent u, and then rationalize with the fancy 1, and you're left with square root of 3 over 3 equals tangent of u. So just like the last time, our solutions will be x equals pi over 6 and 7 pi over 6. But again, we want this in the general form, so we're going to add the period and n times to the form. So you're left with pi over 6 plus pi times n, and 7 pi over 6 plus pi times n. So let's look at one last equation between 0 and 2 pi. As you can see, this one has two different trig functions in it, but you should recognize one of them as part of the Pythagorean identity. So you can change sine squared of x to 1 minus cosine squared of x. Then you'll have 2 times 1 minus cosine squared of x equals 2 plus cosine of x. Then you can distribute the 2 to 1 minus cosine squared of x and have 2 minus 2 cosine squared of x equals 2 plus cosine of x. So then you'll subtract 2 from both sides, leaving you with negative 2 cosine squared of x equals cosine of x, and divide by cosine. So then you have negative 2 cosine equals 1, and then you divide by negative 2, and you're left with cosine of x equals negative 1/2. So the solutions here are x equals 2 pi over 3 and x equals 4 pi over 3. But remember that we're not doing it in general form. This is between 0 and 2 pi, so these are the only two solutions that you'll have for this equation. So that was our last example to solve. So in the morning, we'll take a short quiz over the video and come prepared with any questions that you may have.